Okay, number 46, an isosceles triangle is obtuse. That's sometimes. An isosceles triangle is a triangle that has two congruent sides, so one of the angles could be obtuse in that situation. They also could not have an obtuse angle. A right triangle is equilateral. That's never. We know that because the hypotenuse is always the longest side in a right triangle. And an equilateral triangle means that all sides are the same, so that can never happen. A scalene triangle is obtuse. Could be sometimes. Scalene means none of the sides are the same, so it's possible that it could be an acute triangle. Could also have an obtuse angle. A right triangle is isosceles is sometimes. It could either have two sides that are the same or it could have three sides. It could be scalene. None of the sides could be the same. So we want to now determine the perimeter of equilateral triangle PQR. If PQ is equal to 8x minus 18 and PR equals 2x plus 6, well, we know that it's an equilateral triangle, so all the sides are equal. So I'm just going to set these two sides equal. So I have 8x minus 18 is equal to 2x plus 6. So that means that 6x is equal to 24. So x is equal to 4. So make sure you guys are reading the full problem because this one wants us to determine the perimeter, not just x. So since I have what x is and I have two of the sides, I'm going to just plug in x to one of my sides. So 2 times 4 plus 6 is 8 plus 6, which is equal to 14. If you plug it into PQ, you should also get 14 because it's equilateral. And since we want the perimeter, I know that all sides are going to equal 14. So all I have to do is do 14 times 3 because a triangle has 3 sides, and that equals 42. So I know my perimeter is 42. 51, it says solve for the value of x. Well, I know that this is an exterior angle, and because of our exterior angle theorem, we know that 5x minus 4 is equal to the sum of the two remote interior angles, so that's this angle and this angle. So I know that 5x minus 4 is equal to 4x plus 16. So this is going to be x equals 20. And we're done because they just want us to find the value of x. 52, they want us to name two triangles that are congruent by side angle side if WY and V or XV bisect each other. Well, bisect means to cut in half, so that means each of these opposite sides on the diagonals are going to be congruent to each other. We also have vertical angles all through here. So now we have our side angle side on all of our little triangles, and we know then that opposite triangles there are going to be congruent. So we have triangles WAV is congruent, so WAV, this one right here, is congruent to YAX. So I'm just matching up their congruent parts. And then that means also that WAX is congruent to YAV. All right, 53, determine which triangles are congruent by angle, angle, side. So that means we're looking for two angles right in a row and then a side right after it. And since these are overlapping triangles, I'm going to redraw them. I think it's way easier. The two triangles that I'm going to pull out of this and redraw are ABE, because I noticed the right angle, and then this congruent angle right there. And that matches up with ADE right here, because here's my right angle and here's my congruent angle. So if I'm going to redraw these, I'm going to have my right angle down here, so that's, and my red triangle is going to be D. And then to the shorter side is going to be E, and then my longer side A is going to be down here. And then I have, with my black triangle, I have right angle B here, down to E, and then back up to A. And I know that segment AE has to be congruent to itself, so those are going to be congruent. So now I have angle, angle, side, just like I need. So that means that triangle ABE is going to be congruent to EDA. 54, which parts must be congruent to prove the triangle is congruent by angle, side, angle? Well, we're looking for an angle, a side, and an angle right in a row. So if we have our right angles, which are always congruent to each other, these sides, that means these are the next angles that need to be congruent to each other. So angle T has to be congruent to angle M. Determine which triangles are congruent by angle, angle, side. So again, these are overlapping triangles. I want to redraw them, and I see that I have this angle, and this side, and this side. So to me, that looks like I'm going to do angle ABE right here. And angle, well, actually, I can't use angle ABE because I don't really know of any angles that are congruent. So I'm going to redraw this because I do notice now that we have these vertical angles right in here. So that would mean then that I'm going to use ABF here and DFE right here, because now I have my angle on my side. So if I'm going to redraw these, because overlapping triangles are easier for me to see if I redraw them. So I know this is D. D goes all the way down to E, and this side's congruent, and then it goes up to F, so this angle is congruent up here. And then in my orange triangle, I have my right angle, which is B, up to F, and back down to A, and those sides are congruent. So now I have angle, angle, side, and angle, angle, side. So that means triangle FDE is congruent to triangle FBA. Okay, again, 56, we also have congruent overlapping triangles here. They want to know which triangles are congruent by angle, angle, side. So what I can see here is that they're giving us this side and this side are congruent, and so that makes me think that angle C is going to have to be the same in these two triangles. So I'm going to pull out triangle CBE right here. So CBE is going to be CBE. I know C is going to be congruent to itself, and it's saying that CB is congruent and E. And then we also have, I'll do this in red, CAD. So we have this is going to be CDA. So this is going to be congruent. C is going to be the same, and then this side. So there we have it right there. We have angle, angle, side. So that means triangle CBE is congruent to triangle CDA. Okay, now we want to state why the triangles are congruent if possible here. Now again, remember when you see any two triangles that are touching, that means that side's going to be congruent by the reflexive property. So now if we have those two triangles, we have side, angle, side. Okay, these triangles are a little bit harder to see. We know that we have this angle right here, which is congruent. And then we also have, so we only have our right triangle right here, or our right angle right there, and we have that one side. But let me see, if I know that this is 90 in this angle, if this angle is 90 and this angle is 50, then this angle has to be 40. And if this angle is 40 and this angle is 90, then this angle has to be 50. So now we have some more matching angles. So now if we look at this, we can see that we have angle, angle, side, because we're going to have angle for 90, angle for 50, and then our reflexive side here. So we're going to have angle, angle, side. If we're looking at this triangle in 59, it says that JN and MN are congruent, so I'm going to mark that. I also know that JK and MK are congruent, so I'm going to mark that as well. And then the two triangles are touching, so that's reflexive, so that's going to be side, side, side. 60 tells us that D is the midpoint of MT, measure of angle MDB in T. So MDB is this angle right here, and they're right angles, so I have to mark that they're right. And T are right, okay? And then angles M, and so that's angles M, and ZDT are congruent. So if we mark those, then we have angle, side, angle. So angle, side, angle. All right, so given that ABC is congruent to DEF, find the value of X and Y. So if we can match up corresponding parts in this triangle is what we want to do then. So if we know that, so angle A is corresponding to angle D, so we know angle D, which is right here, is equal to 65. So since I want to find y, I'm just gonna set those two equal to each other because they have to be equal since they're corresponding. So 2y minus 5 is equal to 65. I'm going to say 2y is equal to add 5, so 70. So y is equal to 35. Okay, since y is equal to 35. Okay, now I have to solve for x. So what else? Here's where my x is, and I know that EF is going to be congruent to BC. So I know that 2x plus y is equal to 90.6. Well, I know that y is 35, so instead of writing y, I'm just going to substitute what y is or what y equals. So it's going to be 2x plus 35 is equal to 90.6. So 2x is equal to 55.6. So x is equal to 27.8. Okay, so 62, what is the measure of each base angle of an isosceles triangle if its vertex angle is 26? So I'm going to draw this out just so I can see it. Okay, so I know that my vertex angle is 26, and then since this is an isosceles triangle, I know that these two angles are going to be congruent. Since I'm trying to find those two angles, I'm going to call them both x because I know that they are the same. So all I'm going to do then is I know that the sum of the interior angles has to equal 180 of a triangle. So I'm just going to say 2x plus 26 is equal to 180. So 2x is equal to 154. And 154 divided by 2, so x has to equal 77. Okay, 63 through 65, we're going to look at this picture. So 63 says name an altitude. Well, remember, an altitude starts at a vertex and it goes straight down and hits perpendicular to the opposite side. So if we're looking at this, that's going to be this line right here. So that's SW, line segment SW. Identify the median. So the median starts at a vertex and goes and hits the very middle of the opposite side. So that's going to be this line right here. So that's line segment PT. Identify the angle bisector. So the angle bisector is an angle bisector means it's going to bisect an angle. So VQ is the one that's bisecting the angle right there. So that's going to be VQ. Don't forget to also know perpendicular bisectors as well. Given perimeter 55, we want to list the order of the angles from largest to smallest. So in order to list the angles from largest to smallest, we have to know the side lengths. So we know that the perimeter is 55, and they give us all these side lengths here. So all I'm going to do is do 2x plus 3 plus x plus 2 plus 2x minus 20 has to equal 55. So I have 2x, x, and 2x, so that's 5x. And then 3, 2, and minus 20, so that's negative 15, is equal to 55. So that means 5x is equal to 70. So x is equal to 14. So if x equals 14, I'm just going to plug x back in for all of these sides. So I get 2 times 14 plus 3. So this side is 31. I get 14 plus 2. So this side is 16. And I get 2 times 14 minus 20, so this side is 8. So what this means now is to figure out the angles from largest to smallest. I want to look at the largest side length. So the largest side length in this case is 31, so if my angle directly across from that is going to be angle B. So angle B is going to be the largest. Then I'm going to look, so 16 is my next largest side length, so that's AB. So I'm going to look across from AB, and that's angle C. And then my last one, my smallest length is 20, so I'm going to look across that, and that's angle A. So largest to smallest, BCA. Okay. Next, we're going to order the sides from smallest to largest. So here, instead of looking at the side lengths, we want to look at the angle measurements. So what they've given us is 3 angles, but we know that the sum of 3 angles, interior angles of a triangle equal 180. So in order to first solve for x, we have to set all these equal to 180. So we get x plus 78 plus 3x plus 2 is equal to 180. So I get x and 3x, and I think this is actually supposed to be 2x. So 2x. So that is 6x plus 78 is equal to 180. And then 6x is equal to 102. So x is equal to 17. So now I'm just going to plug in x into all of my angle measurements. So I get 17 plus 78 is 95. 3 times 17 is 51, and 2 times 17 is 34. So now what I have to do is, if they want the sides from smallest to largest, I want to look at my smallest angle measurement, which in this case is 34. So the side across from 34 is BC. So my smallest side length is going to be BC because it's across from my smallest angle measurement. Next smallest angle measurement is 51, so I'm going to look at the side length across from angle C, which is BA. And then my last side is CA, and that's across from my biggest angle. Okay, 68, the measures of 2 sides of a triangle are 9 and 12. Write an inequality that expresses the range of values for the unknown sides. Well, to do this, all you're going to do is 12 minus 9 is less than x is less than 12 plus 9. Well, 12 minus 9 is 3, and 12 plus 9 is 21. So that means the unknown side length has to be between 3 and 21. 69, 2 sides of a triangle are 7 and 14. Which of the following could be the third side? So all I'm going to do is the exact same thing. So I got 14 minus 7 is less than x is less than 14 plus 7. So 14 minus 7 is 7 is less than x is less than 14 plus 7 is 21. So that means I need to find the value that's going to be greater than 7 but less than 21. Well, x can't equal 7, so it can't be 7. It has to be greater than 7, but can't equal 7. 3 is not in between 7 and 21, but 8 is, so my answer is C. 70, name all angles that must be smaller than angle 4. Well, we know that because 4 is our exterior angle, so we know that 4 has to equal the sum of 2 and 1. Well, if it's the sum, then angles 2 and 1 or 1 and 2 must be smaller than angle 4. So your answers here are 1 and 2. Okay, name the following constructions. Well, so right here we have a line that's going through a line segment, and we see that it's making a right angle. So then this means it has to be a perpendicular bisector. Okay, and for 72, we have our segment that is splitting this angle here, so this is going to be an angle bisector. Okay, so now we're on to Unit 6, quadrilaterals. So we first want to just fill in the family tree using the word bank that they give us. Well, we know that we have 3 different types of quadrilaterals. The first one's going to be a parallelogram. Okay, we also have a trapezoid and a kite. And kite's all by itself. We know that a trapezoid could also be an isosceles trapezoid. Okay, and we know parallelograms, they can either be a rectangle or a rhombus. And then either one of those can be a square. Or lead to a square, I should say. They want us to know if this is, if KRAM is a parallelogram, what is AS congruent to? Well, AS right here has to be congruent to the opposite side, or the other half of the diagonal. So it's going to be line segment KS. Okay, they've told us that RSTV is a rhombus, so we want to remember all of the properties of our rhombi. So we know that if RST, so RST, so that's this angle right here, is 67, we want to find the measure of angle RSW. So that is this angle right here. So all we have to do is, we know that in a rhombus that the angles are bisected, so all we're going to do is divide 67 by 2, which is equal to 33.5. We have now for 76, they want us, so I'm going to erase this because we have new information. It's a new problem, new information. So if the measure of angle SWT, so that's this angle right here, is 2x plus 8 degrees, we want to find the value of x. Well, in a rhombus, we know that the diagonals are perpendicular bisectors, so that means that RWT has to be 90 degrees, so that's going to mean that 2x plus 8 is equal to 90. So 2x is equal to 82, so x is equal to 41. And they just want us to find the measure of x, so there we are. So again, I'm going to erase this information because it's new information, or new problem, new information. So if ST is 8, that's this right here, they want us to find RV. Well, in a rhombus, opposite sides are congruent, so it has to be 8. Okay, so now they're giving us the shape, or the quadrilateral WXYZ, which is an isosceles trapezoid with median MN. Okay, so the first question wants us to compute MN if WZ is 11, okay, and I'm going to actually write this the way that we are looking at it. So 11 and XY is 3. Okay, so don't forget we have the mid-segment theory, or the mid-segment equation, so that's going to be 1/2 times base 1 plus base 2 equals the median, or the mid-segment. It's the same wording. So since I know that, I'm just going to plug in my information. So that's just going to be 1/2 times 11 plus 3, so 1/2 times 14, so 1/2 times 14 is equal to 7. So MN in this case is 7. All right, and I'm going to erase this information because it's a new problem, so new information. So if MN is, this is 10x plus 2, and WZ is 21, and WY is 8x plus 19. They want us to find the value of x. So again, all we're going to do is plug in the information based on, plug in the information into our equation so we can find what they're asking us to look for here, which is x. So I'm still going to do 1/2 times my base 1. It doesn't matter which base you put first, but 21 plus 8x plus 19 is equal to my median, which is 10x plus 2. Okay, so what I'm going to do first is multiply each side by 2 to get rid of my fraction. So this means I'm going to have 21 plus 8x plus 19 is equal to 20x plus 4. When I combine like terms and move everything over, I'm going to have 12x equals 36. So that means x is equal to 3. So 3 in this case. Now they're giving us quadrilateral ABCD, which is an isosceles trapezoid, and that we want to decide whether each statement is true or false. So they're asking us if AC is equal to BD. In this case, the diagonals are congruent in an isosceles trapezoid. 81 is AD and CB. Those sides are congruent in an isosceles trapezoid. And they want us to know if CA and BD bisect each other. They do not in an isosceles trapezoid, so that's false. So that's the end of the regular problems. There's also a vocabulary and matching section, which we're not going to go through on the video, but make sure that you go through that and understand the terms that are on that part of the review as well.